Joseph Davidovitz. You run your hand along a limestone face and notice tiny seams that do not look like simple tool marks. He proposed a startling idea. Some pyramid blocks might not be carved. They might be made. The claim is that ancient builders mixed local stone powder and alkali into a paste, then poured it into molds to form blocks that hardened into real stone. Here is the simple image. Instead of hewing huge blocks, you have workshops where mixtures are poured, then stacked like bricks. That idea changes the labor story of the pyramids. It makes the construction less about teams dragging rock and more about chemistry and controlled casting. What makes the argument sticky are tests on micro samples. Some labs found mineral textures that look reformed. Supporters say those textures are the fingerprint of casting. Mainstream geologists answer with a different fingerprint story. They point to natural recrystallization and to quarry evidence. They point to the diary of Merer and to tool marks that match copper chisels. Those records show organized transport of quarried stone. The clash became louder because the cast stone idea threatens a cherished image of organized labor and royal logistics. For some viewers, that sounded like proof someone wanted to hide a simpler secret. For others, it was a spur to do better science. The larger pattern is useful to watch. A careful technical claim sits beside strong documentary records, and both must be weighed. Then a tiny fragment from a lab test appears that does not fit comfortably with either side. That fragment is why the debate did not die. The sample sits under a microscope, and the argument keeps returning to that granular mystery. The microscope found something odd. Tiny rounded particles sat between grains of limestone in a sample from a block near the pyramid face. Some labs read that texture as a sign of reformed stone. Other labs read it as natural recrystallization from groundwater. Both readings are technical and small. For most people, the fight looks like two experts arguing over dust. Here is what matters. The mainstream case rests on strong documentary evidence. A papyrus logbook records shipments of stone. Tool marks consistent with copper chisels appear on blocks. Workers' villages and ramps line up with the logistics story. Those records show how a huge project got done by human hands and organization. On the other side, the geopolymer idea answers one stubborn question. How did builders achieve such uniformity and fit in places where carving seems unlikely? The cast stone idea gives a practical method. If ancient workshops could form stone, the scale of labor and the speed of construction look different. That scenario is technically plausible in small experiments. The missing piece is large-scale archaeological proof. Where are the molds and the factories? This is where the narrative gets human. Advocates see a suppressed shortcut to a truth about ancient skill. Critics see wishful thinking overlaying selective samples. The argument is not a simple conspiracy. It is a disagreement about what counts as sufficient evidence and about how to weigh texts against tiny mineral patterns. So, what should you take away? History is built from many small clues. One grain under a microscope can swing a theory, but it cannot by itself rewrite a civilization. The debate continues. There are other names who followed different clues and found stranger puzzles. Robert Schoch. You run a hand along the worn limestone of the Sphinx enclosure, and the stone feels carved by water, not by wind. The grooves are rounded and vertical. They look like rain that fell for centuries. Schoch, a geologist, pointed at those patterns and said the obvious. If water did this work, then the monument is far older than the conventional date. Here is the claim in plain language. The weathering looks like prolonged rainfall and runoff. The Nile Valley was much wetter long before the age usually given to the Sphinx. Schoch suggested dates as far back as 7,000 to 10,000 years ago. That is a seismic shift. It would put carving in a time most historians do not expect monumental sculpture. The evidence is detailed and patiently gathered. He mapped erosion lines, compared them to known rainfall damage, and argued that the patterns match water action better than sand abrasion. He looked at bedding planes and vertical fissures and found profiles that read like a wet climate signature. For a geologist, those details matter. Mainstream Egyptologists answered with their own evidence. The Sphinx sits in a funerary landscape tied to the Khafra pyramid complex. Quarry marks, tool traces, and architectural context point to a 4,500-year-old construction. Some geologists also note that salt, wind, and varying rock hardness can mimic water-shaped features. That counter-argument is technical but powerful. The drama here is not just stones. It is about how different kinds of evidence get weighed. One field looks at micro-erosion and reads climate. Another looks at context and reads human labor and records. When experts disagree, the public fills the gap with stories of lost civilizations. So which view is right? The truth may be messy. The argument survives because the stone keeps telling a story that does not sit neatly in any single textbook. The restorations complicate everything. Over the centuries, people patched the statue with new blocks and mortar. Those repairs hide original surfaces and create mixed signals. A weathering profile that looks ancient can include modern work. That makes it hard to read the rock like a single clear record. Then there is context. The Sphinx sits next to temples and causeways carved in the same stone. Tomb inscriptions and builders' records place a royal program on the plateau. Those records are not trivial. They are the kind of human paperwork that historians rely on to connect people with monuments and dates. But the geology is not trivial either. Paleoclimatic studies show the region experienced much wetter phases long before dynastic kings. If long-term rain shaped the stone, then a later civilization could have carved into an already altered bedrock. That possibility opens two different histories at once. One history keeps the Sphinx within the known royal program. The other suggests an older stone face that later cultures repurposed. What makes this debate stick is how small pieces of evidence can point in different directions. A vertical groove, a quarry mark, a weathered profile, a later repair. Each one is real, and each one can be read differently by someone trained in a different field. So, how do experts move forward? They gather more samples and map more surfaces. They compare microstructures under microscopes. They test for salts and mineral changes that betray flooding or long-term burial. They use radiometric dating where organic material survives. The process is slow and exacting. That is why heated claims persist long after the first paper appears. Wilhelm Koenig. You lift a cracked clay jar, and the copper glints inside like the buried part of a machine. He unearthed an object in the 1930s that would refuse to be ordinary. A terracotta vessel, a copper cylinder set inside, an iron rod standing in the middle. The arrangement looks, at first glance, like the pieces of a primitive battery. Here is the plain explanation. If you fill that jar with an acidic liquid, such as vinegar, the copper and iron act as electrodes. A small voltage appears. Modern reconstructions show a measurable current. That is the experimental payoff that made the story spread. The tempting leap is obvious. If ancient people could make electricity, then electroplating or simple electrotherapy suddenly moved from modern labs to ancient workshops. The image of a bright piece of technology in the past is irresistible. Now the caution. No wiring, no devices that use the current, no written instructions telling how to make it. The jars were found in a region rich with ritual objects and utilitarian containers. Some archaeologists read the copper tube as a scroll holder or a storage liner. The materials and context match everyday workshops and ritual practice more than a lab for electrochemistry. So why did the battery idea take off? Because it sits in a sweet spot between plausibility and mystery. A simple experiment makes a small current. The public loves a clean experimental result. The archaeological record remains ambiguous. You stand in a lab and connect wires to a recreated jar, and the meter twitches. The current is there, measured, tiny enough to light a single small bulb dimly in a slow experiment. That is the honest result. It proves possibility, but not practice. What could such a current do? It might plate a thin layer of metal on small objects over long time. It might produce a mild electrochemical effect used for simple medicinal treatments. It might have been used in experiments that left no trace. Each idea is plausible on paper. Archaeology asks for more than plausibility. Where are the plated objects? Where are the electrodes shaped into tools? Where are texts describing the method? Nearby sites produce jewelry, ritual vessels, and metalwork that fit known techniques. There is no clear chain that connects the jars to a workshop of electrical practice. The human story adds another layer. The discoverer published and argued his case in an era hungry for ancient wonders. The artifact entered museums and later popular books. That is how a small technical item becomes a symbol. It moves from museum shelf to headline to myth. So the real puzzle is human and not just technical. People want big stories that explain mystery with simple answers. A jar that can be shown to produce current becomes a proof for a larger imaginative leap. The scientific answer is patient and slow. More samples, more context, more tests. Which leaves the question that keeps this name on lists of missing and silenced figures. Ignatius Donnelly. You open a heavy old book, and pages smell of dust and sea salt. He wrote the kind of book that changes how people tell history. In the 19th century, he took Plato seriously and read the Atlantis story as literal fact. He argued that a lost, antediluvian civilization once spanned oceans and taught ancient peoples architecture, astronomy, and engineering. Here is the simple claim. A single advanced island civilization sank in a catastrophe, and its survivors scattered knowledge to Egypt, Mesopotamia, and the Americas. Donnelly pointed to myths shared across cultures and to odd resemblances in monuments and maps. He built a neat mosaic from fragments. Mainstream scholars saw something else. They read Plato as philosophy, not a travel log. They pointed out that myths change with storytelling, and that similar techniques can arise independently. Archaeologists expect material proof under the ground. Donnelly offered patterns and persuasion, but little verifiable excavation. That did not stop his effect. His book created a template. Later, writers borrowed his method. Find a striking similarity, then suggest a single lost source. The story moved from library pages to popular imagination to museum shop calendars. People prefer a single grand origin to messy, gradual change. The lesson here is about narrative power. A persuasive writer can make doubts into facts for a generation. That is how lists of missing scientists gain momentum. The final question is sharp and social. You close the book and feel the weight of an idea that moved millions. He offered a tidy cause for many mysteries. He gave people a single origin story they could hold in one hand. That was the power and the danger. Writers like him do something historians rarely do. They stitch stories into a whole and sell the pattern. That makes complex change feel avoidable and simple. For readers, it is comforting. For scientists, it is frustrating. Scholars replied with patient methods. Excavation teams looked for layers and dates. Linguists compared words across languages. Geologists tested sediments. None of those fields found the single lost source he promised. The archaeological record kept showing multiple independent developments instead. But the story had already escaped the library. Popular magazines, stage plays, and later documentaries repeated the core image. The image seeped into textbooks and tourist brochures. It reshaped how people asked questions about the past. That cultural momentum is real evidence of its own kind. There is a final human twist. People who want mystery and people who want certainty both profit from a lively debate. Museums sell tickets, authors sell books, videos get clicks. That economy keeps dramatic claims alive long after evidence fades. So the chapter ends on a social puzzle, and not a geological one. Which matters more when history is retold? The objects in the ground or the stories people choose to tell about them? John Anthony West. You stand ankle-deep in wind-blown sand, and the Sphinx looks like a weathered sentinel watching a forgotten rain. He was not a conventional Egyptologist. He listened to geologists, and he listened hard. When he found erosion patterns that did not match wind alone, he pushed the question. Could the stone record a much older climate, and therefore a much older carving? His approach was public and theatrical. He paired with a geologist who had mapped heavy waterware on the enclosure walls. They argued that those rounded vertical profiles belonged to prolonged rainfall. If they were right, then the Sphinx might predate the Fourth Dynasty by thousands of years. West used vivid language and public appeals to force the debate into view. He framed the issue as a gap between what stones say and what textbooks repeat. That rhetorical move made the claim a media story and a scientific puzzle at the same time. Mainstream scholars answered with context and continuity. They pointed to tool marks, to temple complexes, and to inscriptions that belong within the Old Kingdom funerary program. They noted that rock hardness varies, and that salt and wind can blur patterns in surprising ways. For many archaeologists, context outweighs isolated stone profiles. The result was a live controversy. One side held a geological reading that looked older. The other held a body of archaeological evidence that fit a known construction program. The dispute remains, because each side uses different tools and different questions. So, where does that leave us? If the geological signal is real, what does it say about lost human labor and vanished knowledge? Andrew Collins. You stand between two standing stones, and the air feels older than the town guidebooks. He travels maps and myths the way other people read newspapers. He looks for patterns in distant monuments and asks if a shared knowledge once moved across oceans. His claim is simple to say. Ancient people in different places carved similar alignments and shared motifs because they carried fragments of an older system of knowledge. He points to alignments with stars, to repeating symbols, and to early sites that seem to show advanced planning like Göbekli Tepe. That argument is seductive. It lets you imagine a hidden school of builders who taught others how to place stones and measure the sky. It gives a neat answer for odd similarities that otherwise look random or independent. Mainstream scholars answer differently. They point out convergent invention. People in many places notice the same sky and the same practical math. They say shared patterns can emerge from common human needs and repeated simple solutions. Archaeologists also demand direct links, such as trade goods, shared technology, or clear transmission routes. Collins mixes field observation with broad synthesis. That makes his books evocative and controversial. Supporters say he revives forgotten questions. Critics say he stitches coincidences into a single seam. The core tension is methodological. One side prefers broad pattern and narrative imagination. The other demands step-by-step material proof. That tension is not a flaw. It is the engine of debate. So the simple human question that remains is this. You stand under a huge carved pillar, and the shadow feels like a page torn from prehistory. He looked at those shadows and asked big questions. He suggested that repeated alignments and motifs across distant sites might be traces of shared teaching or memory. He pointed to sites that predate agriculture and to alignments that match bright stars. He read patterns in stone and in myth. That is the strength of the approach. It moves across disciplines and forces scholars to notice connections they might otherwise miss. Critics raise clear problems. Similar solutions can arise independently when different people look at the same sky. Practical needs lead to similar buildings. Symbols spread by trade do not prove a single vanished school. The demand from archaeology is simple and strict. Show the link, show the trade objects, show continuous transmission. Otherwise, a pattern can be persuasive without being proof. Field archaeologists have pushed back by testing layers and dates and by looking for direct material links. In many cases, the links are thin or absent. Yet the questions he posed stayed alive and inspired new digs and new dating efforts. That is a real scientific contribution. There is a human twist. People prefer a neat origin story. It helps memory and conversation. It also drives books and documentaries. That cultural energy keeps a hypothesis visible long after the initial papers are published. So the final question is both scholarly and social. Konstantin Korotkov. You watch rows of color maps appear, and a technician frowns as readings shift. The images are sensitive. Skin moisture pressure contact area and temperature change the glow. Small procedural differences alter the picture. Researchers who study the device report interesting correlations in pilot studies. Some papers claim links between patterns and stress or autonomic responses. Those early results generate curiosity and more experiments. Other labs try to reproduce findings and get mixed outcomes. Reproducibility is the central issue. Critics say the method confounds easily controlled variables. They call for blind studies, large samples, and consistent protocols. They point out that many published claims come from groups with a stake in the outcome. That does not prove bad intent. It does mean we must be careful about reading meaning into images that change with humidity. Supporters argue this is a new window into subtle phenomena long described in spiritual traditions. They say the camera is doing what words once did. That narrative has cultural traction because it promises ancient wisdom validated by modern tools. Clinics and wellness centers adopt the technology for assessment and biofeedback. That creates a feedback loop. Public interest funds more studies and more devices. The science and the market begin to shape one another. So, what do we hold as evidence? A single lab result that can be repeated under strict controls, or a powerful cultural story that feels true and spreads fast? Which should move the field forward, measured replication or popular enthusiasm? Nicola Tesla. You step into a vast room and coils hum like distant thunder. He built machines that made lights dance and motors run. He championed alternating current, and he gave the world practical electricity. He invented the resonant transformer we still call the Tesla coil. He dreamed of wireless power sent through the earth. Here is what is true. He patented major electrical systems that changed the modern world. He experimented at Colorado Springs, and he tried to build Wardenclyffe to test wireless transmission on a large scale. He proposed bold ideas, and he filed patents for many of them. Here is what feeds myth. He spoke of radical ideas that sounded like magic to the public. He died in a New Yorker hotel room in 1943. Shortly after his death, government agents collected some papers for inventory. That official action is a fact, and it fuels speculation. The myths leap further. Some claim the government seized working free energy devices. Others say secret agencies hid discoveries about ancient power. Historians and archivists who have examined the files find no evidence of a functioning free energy machine. They document his financial troubles and his lonely final years instead. So why does Tesla attract claims of suppression? He combined real genius with showmanship and solitary reputation. He promised far more than anyone could fund. That combination invites rumor and conspiracy. The sober takeaway is both simple and strange. A brilliant inventor left real transformative work and also unanswered ideas. Which is more dangerous for history, a genius who fails, or a genius who is turned into a legend that hides the messy real record of how technology actually progresses? After his death, government agents did collect papers. That is a documented fact. Officials inventoried the material and secured it. Most documents later went to libraries and museums. Historians who examined those files found correspondence patents, drafts, and notebooks. They found ideas and sketches. They did not find evidence of a functioning free energy machine. That is important because public imagination prefers a tidy villain. A secret agency that hides a finished device is a strong story. But archival work tells a different story. It shows a brilliant mind that made real contributions to alternating current to radio technology and to early wireless experiments. It also shows financial failures and unfinished projects. Wardenclyffe was an ambitious plan. He never fully funded it. The structure was dismantled. Financial papers show investors and strained budgets. That is a quieter reality than a dramatic seizure narrative. It does not diminish his genius. It explains how promising ideas can die for business reasons rather than because someone hid them. The archives and declassified files are a slow answer to fast rumor. They do not make for headlines. They make for scholarship. They show how ideas move from lab bench to market or vanish into debt. So where does that leave the Tesla myth? It leaves a picture of a man who inspired wonder and who left real inventions for the world to use. It also leaves a warning. When genius meets hardship, people will invent conspiracies to fill the gap. Carl Baugh. You push open a small museum door, and the air smells of polished wood and labels. Cases hold objects that do not fit neat timelines. He built a public stage for the strange. He collected artifacts he said came from deep strata and from places that would rewrite prehistory. What he claims is bold. He shows metal objects in geological layers that mainstream science dates long before such metalworking should exist. He argues that those objects are proof of advanced ancient knowledge. He stages exhibits and he films fieldwork. He asks the public to look and decide. Supporters praise his persistence. They point to curious finds and to interviews with locals who reported odd discoveries. They say mainstream archaeologists ignore uncomfortable evidence. That narrative is powerful because it flips the authority dynamic. A lone researcher stands up to institutions. Critics are blunt. They question provenance. They demand clear excavation records, chain of custody, and independent dating. They point out that objects without secure context are almost impossible to date reliably. They note that high-quality labs and peer-reviewed publications are the gold standard. When those are missing, the claim remains weak. That contrast is the chapter tension. A museum case and a dramatic claim do not replace rigorous method. But a dramatic claim can force scrutiny and new research questions. The social power of spectacle also matters. People remember a museum exhibit more than a dry academic paper. So, what should you believe? When a single collector presents objects that challenge timelines, do you trust the display or the lack of published provenance documentation? You stand close to a glass case where a curious metal fragment sits on velvet. The label says it came from a deep layer. The collector points at the strata photographs and tells a story that would rewrite timelines. Here is the central issue. Provenance matters. Objects without a clear excavation record cannot be tied securely to a date. A hand found at a site by a trained team is different from an object that changed hands many times. Chain of custody is a simple phrase with huge consequences. Laboratories can test composition and trace elements. They can try to date associated organic material. Independent teams can examine tools and wear patterns. When those steps are done and published in peer-reviewed journals, then claims move from spectacle to evidence. In many contested cases, the tests do not exist or are inconclusive. That is not always fraud. Sometimes it is messy fieldwork and lost context. Sometimes it is honest error. But the result looks the same to other scientists. The claim remains unproven. The public sees a dramatic display and remembers the story. Museums and media reward the vivid image more than the careful caveat. That social amplification creates a cycle. Claims get repeated. They become part of popular imagination. So, what is the responsible choice for a curious person? Believe the dramatic display and demand a full reassessment of prehistory, or demand rigorous publication verification and accept slower revision? Which path leads to better history, and why would anyone prefer one over the other? Stanley Hall. You find his name on a list, and it feels like a missing person mystery. The story says he uncovered ancient tech and then vanished. It sounds cinematic and it spreads fast. Here is the fact pattern. In fringe literature, his name appears often. Websites and videos repeat the tale. Yet careful searches in archives and academic records turn up nothing reliable. No field reports, no peer-reviewed papers, no contemporary newspaper accounts that would normally accompany a major disappearance. That absence matters. Real scientists leave traces. Lab notes, institutional records, colleagues who write about them. When those are missing, a claimed disappearance likely rests on rumor or confusion. So, how does a name gain traction? First, someone lists it in a dramatic article. Then, other writers copy that list. Then, social posts and videos repeat the claim until the name feels familiar. Finally, the myth enters oral culture and becomes hard to dislodge. There are other pressures. People want a neat villain who silences truth. They want a hero who discovered a suppressed secret. Those narratives are emotionally satisfying. They are also poor substitutes for evidence. The skeptical view asks for verification steps. Check university rolls, search national archives, find contemporary press, ask museums and colleagues. When none of that exists, the only honest conclusion is uncertainty. That conclusion is unsatisfying to those who crave revelation. It is essential for those who value truth. So here is the question that closes the circle. When a name can spread faster than records can confirm it, what do we owe the past and each other? Do we tell dramatic stories, or do we demand documents that make a claim real? You open a dusty file, and the room smells like old paper. Real scientists leave traces in archives, lab notes, institutional letters, field reports, newspaper records. Those things tell a story you can check. When a name appears only on lists, check simple things. Search university rolls and professional directories. Look for peer-reviewed papers. Ask museums for accession records and provenance details. Search contemporary newspapers and official death records. If none of that shows up, treat the claim as unverified. Why does this matter? False names confuse real history. They waste research time and lend weight to wild theories. They also hurt public trust in science. That is not a small problem. It makes it harder to spot real suppression when it occurs. Peer review is central. It tests methods, data, and interpretation. A claim backed by blind studies, multiple labs, and published results moves into the realm of demonstrated fact. A name repeated on social posts does not. There is a human side, too. People love mystery. They want heroes and villains. Names that vanish make compelling stories. That emotional pull explains why myths spread faster than archives. So here is the practical lesson. Be curious and be skeptical. Demand documentation. Ask for independent verification. Celebrate discoveries that survive rigorous testing. Which is more important when you read a dramatic list, the thrilling story or the documents you can check? Who gets to decide which names become part of history and which remain cautionary tales?